Okay, so the question is, how do you do these lower and upper sums for more than like 5 or even 10 rectangles, like 50 or 100 or 500? So obviously this is on the calculator portion. So let's grab our calculator right here. And I've graphed the curve y equals 4 over 1 plus x squared. Change the window a little bit. We're finding the integral from 0 to 1, so we just need to focus on that piece. So let me take a picture of that. Let's send that over. And then we can get rid of the calculator. And here we go. Okay, so we're going from 0 to 1. So let's say, for example, we want to do 100. And let's say we'll do the lower sums. So here's 1. So that means that we're going to put 100 rectangles between 0 and 1. So how wide is each rectangle? Well, my delta x is going to be the interval length, which is 1 minus 0, divided by how many rectangles. So that's going to give us 0.01 or 1/100th. So that's the width of each rectangle. So I'm going to over-exaggerate this. So let's say this is your first rectangle. And let's say I want to do the lower sums. So this is going from 0 to 0.01. That's that first rectangle. And what I'm going to want to do, and this is my function f. So what I'm going to want to do to find the area of that rectangle is I'm going to take the width, which is 0.01, and then multiply that by my function evaluated at the right side of the subinterval. So I'm going to evaluate it at 0.01. If I wanted to overestimate the upper rectangles, then I would make my rectangle go up at 0 to the graph. Keep going. So it would go up to here. And so then that would overestimate, but I'm just going to do the lower right now, and you should be able to do the upper if you need to. Alright, so then what's the next one going to be? Now, by the way, the width of all these rectangles is the same. So I can actually factor out that 0.01, the width of my rectangles, and then just add the heights of all the rectangles. So what's the next one? Well, the next subinterval will go from 0.01 to 0.02, and since this function is decreasing, the lower value will be, again, at the right side of the subinterval, so I'm going to evaluate my function at 0.02, and so on and so on and so on. And then when I get to the end, of the whole interval, which is 1, I'm going to want to make my rectangle, and this will be 0.99. I'm going to evaluate it at 1 to get the height of that rectangle. So I'm going to do, switch colors. So I want to evaluate it at f of 1, or 1.00. There. So this is going to give me my lower approximation. I'll call it L sub 100. Now, obviously we don't want to do that by hand. So there's a couple ways that you can do it depending on which operating system you have on your calculator. So the 0.01 is a constant. I can actually put that outside, and I'm going to write this as sigma notation. And I'll let n be my index variable, and I'm going to go from 1 to 100 because there's 100 expressions here. The first one we're evaluating at 0.01, then 0.02, all the way up to 1.00. So that's 100 different terms. So I'm going 1 to 100, and I'm going to evaluate f times 0.01 times n. So when n is 1, I get 0.01. When n is 2, I get 0.02, etc. When n is 100, I get 1, and that's the last term. Now we can do this on the calculator very easily. So let me call the calculator back up. Now I have this function already in y1. That's important that you have that there. Now, if you press alpha and the window key, if you get one of these menus, then you can follow along. If you don't, I'll show you how to do it without it. But we have a summation, which is number 2 on that list. So that's the one we want to use. And so now my variable I'm just going to choose n, and it's going to go from 1, hit the up arrow, to 100, right arrow. Now I want to evaluate what's in y1, so I'm going to press alpha trace, and there's y1. And then I need a parenthesis because this says I want to plug in a value to evaluate y1 at. And then what do I want to do? I wanted to do y1 of 0.01 times n, just like I had written in the expression. And then I'm going to take that answer, and then don't forget to multiply by the 0.01, which is the width of each rectangle. So maybe I'll put that in now. Times 0.01, that's the width. Jump to the front, insert a parenthesis there. Okay, so I'm going to add up the function values from 0.01 to 1. That's going to be the heights of all my rectangles. Add those together and multiply by 0.01. And this gives me the approximation for 100 lower rectangles. The directions said, I'm not sure how many decimals, so 3. Let's say 1316. 3.131, actually let's take a screenshot of this. Screen capture. Let's go back. Sorry, I'm doing this all on the fly. So, there we go. Send. And go back to here. Put this down here. There we go. Okay, so, and that's how you do it. That's it. Now, what if you don't have those shortcut keys? Well, you could always do it the long way. And to get this same expression by hand, you would press second stat, and then you go over to math, and number 5 will sum up. And that's what we're going to do. We're going to sum up stuff. Now, what do I want to sum up? Well, I actually need a sequence. So I need to press second stat again, and this time go over to ops and choose number 5, which is create a sequence. Now what's the expression here? Well, I'm going to press alpha trace. Oh, by the way, and if alpha trace doesn't work for you, you can always go through the vars button. Hit vars, go over to y vars, go into function, and then there's your y variables. Okay, clear. Oops, so I got to start all over. So second stat, go over to math, number 5, sum up, second stat, go over to ops, number 5, sequence, expression, we want to put y1, parentheses, 0.01, I'll just use x, doesn't matter what variable because you can specify it here. My variable is x, I'm going to start at 1, I'm going to end at 100. And this actually allows you to step other than integer values, but we're just going to step it at 1. That's what our sigma does. And then we can paste, and then multiply that by 0.01. And there we go, same answer. Okay, so hopefully that helps you figure out how to do many rectangles.